In this video, we'll learn about virtual and dynamic binding. The topics that we are going to cover under this virtual and dynamic binding are pointers to derived objects, virtual functions, dynamic binding, pure virtual functions, virtual destructor, and this pointer. This will be our last video possibly, or we can split these topics into two. First, we go for pointers to derived object, virtual function, and dynamic binding. Let me explain that in one video, in this video. And in the next video, I'll explain about pure virtual functions, virtual destructor, and this pointer. First, we see about virtual functions, pointers to derived objects. We know about pointers, but we never learned about how to use pointers in a derived object. So you might be wondering why I mentioned something like pointers to derived objects. Why not pointers to base objects? Let me tell you here, when I say about pointers to derived object, it doesn't mean that we are going to create pointers for the derived object. Usually we create a pointer for the base object, for the base class. That's how it works. But it automatically applies for the derived object too. You can see here we can use pointers not only to the base objects and also to the derived classes. So I have given a small example where I can mention a pointer something called star PTR. So anything with star symbol, we call that as a pointer variable. So this PTR is my pointer variable that has been created for the base class. So next step, I have an object for the base class that I've created and D as an object for the derived class. So imagine we have a base class and derived class, and object for base class is B and object for derived class is D. Usually we create an object for derived class, we don't create an object for the base class, but here it's all going to be in a different manner. We have created object for both base class and derived class. Now I have a pointer that also created for the base class. Now next is, if I create a pointer, this pointer should hold the address of some variable. That's the next thing. Since I create a pointer for the base class, so I can store only an object's address into the pointer. Understand this point clearly. I created a pointer for the base class, so I can have only the address of an object into this pointer. So come here. So for this pointer, first I am assigning the address of the base object. So B is a object for the base class. That address is passed into the pointer, and then I can able to access any properties or any functions or variables from the base class. So next I say pointer equal to address of D. That means the derived class's object address is passed into the pointer. Now you might be wondering, now I can able to access the derived classes member functions using this particular line. But that's totally wrong. You can't do that. Even if I am passing the derived classes address into the pointer, I can only able to access the base classes detail, not the derived classes detail. So you might be asking then why I need to pass an address of a derived class into a pointer. I'll show that with an example when we create a program, why we have created or why we have passed the address of derived class into a pointer. Let me complete this first. Here, the last line I say using PTR or using the pointer, we can access only those members which are inherited from base and not the members that originally belong to the derived. So always you can inherit only from the base and not from the derived. So that's not going to fulfill the property of polymorphism, and that's not going to help you how this derived classes details are not going to be inherited. That's a very big question, how I am going to access the derived classes members using this base classes pointer. To achieve this derived classes member function using the base class pointer, I have to introduce a concept called virtual. Only using virtual I can able to achieve this polymorphism. I can able to access or I can able to inherit the properties from the derived class. Here it says when we use the same function name in both base and derived classes, The function in base class is declared as virtual using the keyword virtual preceding its normal declaration. Uh, I'm going to show an example where both the base class and derived class having a same function name with same parameters. So when we have same function name with same parameter, we call it as overriding. So in this example, we are going to see about how the overriding also works. So when we use the same function name in both base and derived classes, the function in base class is declared as virtual using the keyword virtual preceding its normal declaration. Only if you make a base class's function as virtual, only you can do for base class. You can't make a derived class as virtual, that's not possible. When you do so, I can able to access a derived class's member function. So here I said I can't able to access a derived classes details, but using the virtual, I say we can able to access a derived classes details also. So when a function is made virtual, C++ determines which function to use at runtime based on the type of object pointed to by the base pointer rather than the type of the pointer. Understand this line? It's based on type of object pointed to by the base pointer rather than the type of the pointer. So keep this point in your mind about this pointers to derived object and virtual function. So here what I said is I create a pointer for the base class. I pass the address of both base and derived class, and I told you that I can able to access only the base classes details and not the derived classes detail. So we are going to find a solution how to access a derived classes member functions or member variables also. That's one thing. And here I give a solution. When you make a base classes function as virtual, you can able to access a derived classes member function. This is the second thing which I'm pointing out. First, be very clear about this point. The variable can't be accessed when I use a statement like this. Here I say using virtual, I'm saying we can able to access a member function in a derived class. So before getting into the program, let's see the properties. The rules for virtual function, a few properties to keep in mind. First one, virtual function must be members of some class and they cannot be static. They are accessed by using object pointers. So virtual function can be accessed only using object pointers. A virtual function can be a friend of another class. A virtual function in a base class must be defined even though it may not be used. So you can't declare just a virtual function, you have to define it. And we cannot have virtual constructor, but we can have virtual destructors. Virtual function works under overriding function. So keep all these points in your mind. We're not going to apply all these rules or all these properties in the program that we are going to discuss. But when you're having any requirements or any programs which you're going to create using a virtual concept, you have to keep all these properties in your mind. So now let's see two programs, one for identifying how the pointers are used in a derived objects, how we create a pointer for the base class. And I told you we can't able to access a derived classes properties using a base classes pointer. So let's see that and we find a solution how to access that. And second, we see a virtual function program that is a dynamic function. We don't have any explanation over here in the PPT for dynamic binding. When I say dynamic binding, it's nothing but your virtual concept. The other name for dynamic binding is late binding or runtime binding. These are the other names for dynamic binding. It's an example for virtual function. When I say virtual, it can be identified only during the runtime, not during the compile time. It will be accessed or it can be identified only during the runtime. That's a concept of dynamic binding. So we see two programs, one for pointers to derived object and virtual function, and another one is exclusively for virtual function. That's for dynamic binding. Let's get into code blocks. I have a program which I created that is virtual1.cpp, and I have a class called base. So I'm going to have a single inheritance concept. That means one base class and one derived class. Here I'm going to explain the concept of introducing a pointer for the base class, and using that pointer how we are going to access the properties of the base and as well as from the derived. And I told you, using the base classes pointer you can't able to access the derived classes properties. So keeping that in mind, so let's create this program. Let me have one variable in the base class and one function to display that variable. Likewise, in the derived class, let me have one variable, and let me have to display both this base class variable and derived classes variable. So let me give the access specifier as public. Let me have one variable and one common function. I told you we're going to use a overriding concept. So let me say show off. I'm going to display this variable. So a equal to a and l. That's it. So let me create the derived class. Let me say the class name as derived. Now it is going to inherit the base classes property using the public visibility mode, public base. So inside derived class, let me have the access specifier first, and let me introduce a variable as b. And again, I have to use the same function name with same parameter. If you change the parameter, then that becomes function overloading. So don't do that. We need to use function overriding. So void show off, void show off. Both the classes having the same function name with same parameter. This is an example for function overriding. Here I'm going to display both a and b. Alright, so the inheritance purpose. So here I'm displaying the value of a also. A is also going to be called here, and b, which belongs to the derived class, that is also going to be called here. Now let me get into the main function. In the main function, usually we create a object for the derived class and then we try to access the functions or variables in the base or derived class. But this time we are going to create a pointer for the base class. So my base class's name is base, and I create a pointer. Pointer always starts with the asterisk symbol and the variable. If I say star p, that's a pointer. So now I have created a pointer for the base class. Now let me create an object for the base class. So let me create b as an object. Now, so I have an object for base and I have a pointer for base. So pointer always holds an address of a variable. Since we have created a pointer for the class, it should hold the address of an object. So p is equal to, that means my pointer is equal to, it's going to hold the address of this b. So ampersand b. So if you want to access any properties, that means any variable or function name from the base class, instead of using the object, now I can use the pointer. So if you use an object, say example b dot, and then you use a function name as show underscore off. This is what you do, but this time you're going to use a pointer. So p is a pointer. If you're using a pointer, you can't use a dot membership operator. You have to use an arrow symbol. That means a hyphen and the increasing or symbol. So that's going to give an access for show off function. Please remember, if you're using an object, use dot membership operator. If you're using pointer, you have to use an arrow symbol to access any member variable or member function. So this is one thing. So let me check the output. So return 0, and let's check whether we get the output. Yeah, we got a equal to 8. Is this what I gave? Did I give the input for a? I didn't give any input here, but it's defaultly taking the value as a. You can check here. I didn't give any input, so defaultly it has taken some garbage value as 8. So make sure that you give the value for 8 and then go for the display. I'm sorry, value for a and then go for the display. So I need to assign a value for the variable a. Usually any function or the member variable, if you're calling, you have to use the object name, but here we are using the pointer. So use the pointer p to assign a value for a. So let me say a equal to 100. So using the pointer I have given the value a equal to 100, and now I'm calling show off. This should give an answer as a equal to 100. Okay, so earlier we got a equal to 8. That's a garbage value. Since I didn't give any input, it automatically took some value. Okay, so base is done. Now let me create an object for the derived class. So I created an object. Now inside the pointer, let me give the address of derived. And inside the derived class, you can see I am calling both a and b to display. So let me assign the value again for a. Let me say a equal to 200, and then I say b equal to 300, and then I'm calling the same function show off. So any guess what's going to be the output? And here it is going to give the output a equal to 100. That's for the base class. Now I have copied the address of derived object into the pointer, and I'm calling p arrow a equal to 200. Is that going to pass any error here? Let's check that. And then I say p arrow b equal to 100. I say a equal to 200 is not going to pass any error, as because a belongs to the base classes variable. But here this pointer is trying to access the derived classes variable b. Here it's going to pass an error. Since I told you very clearly, even though you create a pointer for the base class, the base classes properties can be accessed, but not your derived classes properties can be accessed. You can't modify or you can't give a value for the derived classes variable. Let's check, is it going to pass any error or not? Yes, it's pointing an error. You can see in the same line. Let's see what it says. Class base has no member named B. Again, it's going to the base class and checking and saying it doesn't have anything called B. So let me hide this assigning part for B, and now I say using the base classes address, I'm calling the pointer and I say a equal to 100. Using the derived classes address, using the pointer, I'm saying a equal to 200. So for the first a equal to 100, it goes for this function. It says a equal to 100, and for the next one it goes for the second show of function. Is that so? Is that going to call the second show of function and say a equal to 200? Let me check that. Let me say um, see out, this is my base, and here let me say this is my derived. Okay, now I have given a equal to 100 using the first base classes object using the pointer, and using the derived classes object I'm saying again a equal to 200. So let me check. You might be thinking this a equal to 100 will call the base classes show off, and this a equal to 200 is going to call the derived classes show off. Let's check which one it is going to call. A equal to 100 calling the base class. Again a equal to 200 is calling the base class. So how many times you call the variable a, it's going to call only the base and not the derived. Why is it so? Is that because I'm giving b equal to b, something like this? Okay, so if you want to make that clear, let me hide this. I'm not assigning b, or I'm not saying anything as b equal to so and so. I'm not touching anything related to b. The same thing, whatever that I have in my base class, here I say a equal to so and so, that is present in the base class. Again here I am saying a equal to so and so, but that is present in my derived class. So same function name show off, calling the same variable a equal to, but this belongs to base, this belongs to derived. Now let us check. The same output. I keep on calling the base and not the derived. So to avoid this, see, here we don't achieve any polymorphism, here we don't achieve any inheritance. Nothing is working fine here, as because it keeps on calling the base class but not the derived classes function. So that's a problem. To avoid this problem, we introduce a concept called virtual. So that's what we are going to see now. So you can't make a derived classes function as derived. Only I can make a base classes function as virtual. I'm sorry, virtual. So don't make the derived classes function as virtual. That's going to pass an error. So I'm making a base classes function as virtual. So now what happens? When I call the base classes object, when I pass the address into the pointer and I assign a variable a equal to 100, and if I call show off, this is going to call the base class. And now when I pass the address of the derived classes object into the pointer, and using that pointer, if I call a again as 200, this is going to call the derived class, as because what it does is it looks whether the show of the same function has been used a virtual concept. So if I use virtual in base class function, automatically it jumps to the derived class and it calls the derived classes function. That's the beauty of it. So let's check. See here, a equal to 100 from base, a equal to 200 from derived. So this time successfully I am calling the derived classes function, as because I made the base classes show off as virtual. I hope you are clear about how to use a function as virtual, at what situation we make a function as virtual. Be very clear with this. So hope this concept clear. Now let me skip this virtual right now, or let it be. Let me skip this right now. I'm not using any virtual here. Let me have this integer b again, and let me have this, all this. Now is there any way for this previous program, before introducing virtual and all these things, is there any way can I able to call the derived classes variable b, and can I able to assign it? Of course we can do that, but we can't do with the base classes pointer. So in that situation you have to create a new pointer for the derived class. So let me introduce derived, and I create a pointer called PD. So pointer for derived. Now you can assign in this PD the address of my derived class. Now say PD arrow b equal to 300, and now call the function PD arrow show off. So now I give for the base classes pointer a equal to 100. For the derived classes pointer again a equal to 100. We know that both a equal to 100 and b equal to 100 is going to call the base classes show off. I'm using show off here, show off here. These two show off are from base. This time I'm creating a pointer for the derived and I'm passing the address of derived classes object into the pointer. And now you can see using the derived classes pointer, I'm assigning b equal to 300. Using derived classes pointer, I'm calling show off. So this time this passes to the derived class. Let's check. Yeah, a equal to 100, that's for base. A equal to 200, that's for base. And next time it says a equal to 200 and b equal to 300, that's for derived. That's because I call this b equal to 300 using the derived classes pointer. And this a equal to 200, that's been called from a base classes pointer. So while you're displaying, I'm calling this a and b with a separate pointers. Understand that. So you might be wondering, sir, it belongs to the same function. How can it can able to call a and b at the same time? Remember, a called using the base classes pointer and b is been called using the derived classes pointer. That's how we can able to display base classes detail and derived classes detail using the pointers separately for base and derived. So it might be quite confusing. Please play back this video again if you have any problem in understanding what we have discussed so far about how to introduce pointer for base and derived and how to use virtual for the base classes function. At what situation we have to introduce the base class function as virtual. So this is about pointers to derived object and as well as for virtual. So let's see one more program to understand this dynamic binding, same virtual function concept with another program. So in that program, we are going to see some new concepts also. We are going to see how to dynamically allocate memory for a variable. And we are also going to see this overriding concept. Again, we are going to see about how to make a base classes function as virtual, at what situation we make that as virtual, and also we are going to see how we can introduce an array of objects or array of pointers. Is it possible to do so? We usually introduce just b or just p. Can I use something like this, like array of for pointer or array of for object? Let's see using the next program how to introduce all this. Here we have created a second program, virtual2.cpp. Uh, the concept before getting into the program, we are going to have not a single inheritance concept. Here we are going to have one base class and two derived classes. So I hope you know to which type it belongs to. So when you have two base class and one derived class, we call it as multiple inheritance. When you have one base class and two or more derived class, we call it as hierarchical inheritance. So here we are going to follow hierarchical inheritance. That means I have one base and two derived class. Here the logic is, let us take an example to introduce this virtual function. Consider a bookshop which sells both books and videotapes. That means using the hard copy and as well as the soft copy. So we can create a class known as media. So let me create a base as media that stores the title and price of a publication. any book, any author, anything that you want to say, this base class is going to have the title of the book and as well as price of that book. Both are going to be included inside the base class. So next we are going to have two derived class. So one derived class is going to store the number of pages in a book, and another one is going to store the playing time of the tape. So one derived class is going to have the number of pages since it's a hard copy, and the next derived class it is going to have the playing time of the tape since it's a soft copy. So let's see, with the base class and derived class we are going to use constructor also. So it will help you to recap again how to use constructor in a derived class and all the other topics also. So first I have a base class as media. Here we'll be introducing this constructor. So before that we have to mention the data members that is being mentioned as an example. So let me give all these under protected. It doesn't matter, you can also keep it under public also or private also, not a problem. And title and price, these two are going to be stored under base class. So when I say title, book of the author, it is going to be a very lengthy one or maybe a short one, but it's going to be a string. So I'm going to introduce star and let me say title, and let me give the array size here as something as 50. I hope you know how to use array of variable. When I say title of 50, it's going to allocate a space from 0 to 49. So any length between 0 to 49 is going to be accepted for this particular variable. So I say character, title, it's a variable name, and I assign an array size of 50. A maximum of 50 characters can be stored inside this array space. Excuse me. So next it is going to be price. So price can be in float, and maybe in decimal. So let me say float price. So these two are the data members. So next is a member function. So let me have two functions here. One is going to be a constructor, another one is going to be a normal function. So constructor, so if you remember how the constructor has to start, it doesn't have any return type, it always starts with a class name. So my class name is media. It's going to be a parameterized constructor since we have title and price, those two need the values. So first it's going to be character and it's going to have a pointer. Why I'm using pointer here is I'm going to get character in arrays. It's not a single character. When I say character yes, it accepts only one character. When I say star yes, it's a pointer. It holds the address of this title of 50. So using this pointer, I can access all the characters that is present inside this title variable. That's the reason I have introduced pointer. Remember, if it is yes alone, one character. If it is pointer yes, it can access the number of array size that is defined in this variable. And next is going to be float. So let me say a. Now let me assign this yes to title and a to price. So usually we say title equal to yes, and next we say price equal to a. So for a change, here I can use a new keyword called string copy. Since I want to teach you all this in one single program, why I am using string copy? So what I'm going to copy here? So we know when I use title equal to yes, whatever that is present in yes or whatever I give in yes is going to be copied into this title. That means array of 50, it's going to copy. Use the same title and yes inside this keyword. I use title, comma, yes. Just look at the difference between these two. I say title equal to yes, we don't have any problem. I say string copy title, comma, yes. Both are going to be same. But to make you understand, we have a keyword also can be introduced to copy whatever that is present in yes to title. So let me use this. my book name, I give an yes, comes here and copies into title using the keyword strcpy. That's a keyword. And if I want to introduce this keyword, I need to introduce one more header file here. Let me check if it is passing any error. For example, if it passes error, we need to introduce a keyword for accessing this keyword. Remember, IO stream is only for cout and cin. Apart from that, if you introduce any new keywords like a new keyword like string copy, then I have to introduce one more header file. So let it be as it is. If at all, if there is any error, let's see what we have to do for that. And next is going to be a normal function, say void display of, and let me keep this function as empty. I'm just saying it is a base display. I'll tell you why I introduce a function like this and I'm not doing anything over here. There's a reason, since I'm going to use the same display of in both the derived classes as a overriding. So if I use overriding in the derived class, it's must that you must have the same function in the base class also. That's the reason I use this display. Let's move on. So first derived class, let me name that as book, and it's going to inherit the base class, say media. Now here I told you it's going to check the number of pages, so let me introduce pages, and then let me introduce the access specifier public. And if I introduce constructor in a base class, it is mandatory you should have a constructor in other two derived classes also. So here the derived class, the class name is book, so I say book. And before giving the value for pages, make sure you're giving value for the base classes details. So let me copy the same. I say character star s comma float e. And now you can give for this pages. So that's a return type is integer. So let me say integer p as pages. Now how this is inherited, the base and derived are inherited the same way. The base derived classes constructor and base classes constructor also should inherit. So I have to use colon, and here their constructor name is media, so media, and use the same variable s comma a. You can use the same variable since it's a separate class, so it's not going to pass any error. Now let me define this constructor. So s and a, it will be given from the main function, so p alone has to be assigned. So let me say pages equal to p. Again I'm going to have the same function display of. Here I'm going to give what all I need to display. So here I need everything in order. First the title should be displayed and price should be displayed and the number of pages. Let's go in order. First title to be displayed, and next price, and now pages. Okay. So same like base class, I have a constructor and as well as a normal member function. So here in the member function, there I did nothing, just to make sure I have a function called display. Here I am printing all the necessary information to be displayed in my output screen. So let me move on to the next derived class. Let me name that as tape, and this is also going to inherit from my base class media. Okay, so here it's going to be time, isn't it? So I'm going to record the number of the duration of the tape, soft copy of the tape. So it can be in float, might be in decimal. So let me say time, that's what I'm calculating, and public access specifier. So again constructor, so tape is the class name, And again I have to give all the base classes details. Character star yes, float EA, and now I have to give for this time, so it's also in float, so let me say T, and same, it's also going to inherit the base classes constructor media, use the same variable yes comma A. Now this time should be assigned, so time is assigned with T. So let me introduce the same overriding function display of. All these are going to be same apart from these pages. Instead of pages, um, let me say time, playtime, that will be meaningful. Playtime. Here I give, here we have given us time, isn't it? So time. Okay, so we are done with one base class and two derived classes. Let's jump into the main function. In the main function, what all I need to give? I need to give for everything. That means starting from title, price, and comes to first derived class pages, second derived class time. So title, price, pages, time. All these values has to be given here. So I need to mention the return type. First one title. So I say character, and pointer. Let me say title. I'm introducing something new. You can give something like this also. You can say character title of again 60 or something. Sorry, 60 semicolon, and then move on to the next one. Let me say float. What are for float? Price comes under float, and time also comes under float. And one more remaining. What is that? Pages. So that's integer return type. So pages integer return type. Here I'm going to make a small change. This is acceptable. Another way, I can introduce a dynamic memory allocation. Instantly I can allocate a memory. What are the steps we need to follow? First, make this as pointer and equal to a new keyword called new. That's a keyword. When it appears in blue color, that means it's a keyword. That's a quite interesting thing. We introduced this for dynamic memory allocation. That means instant memory allocation. Here I say the size is 30. So both these things, even you can say like this also, title of 30. These two are same. When I say character title 30 and character start title equal to new character 30, both are same. This way of allocation is a static allocation. Remember, it remains until you complete or remove the program. This space is going to be forever. That means the space 30 is going to be forever. But when I say start title equal to new and then character 30, that means I'm dynamically allocating memory. That means once I get out of this program, automatically this memory is going to be erased. That's the difference between a static allocation and dynamic allocation. So this is one important thing, dynamic memory allocation, how to allocate memory dynamically, instantly how you can allocate it. This is an example. All right, all the declaration part is done. Now I need to give the respective values for all these allocations. So starting with title the book. So here let me give C in title. Here's where I give and C out. So price is the next one. C in. Let me say price. And next I'm going to give for, let me take the first derived classes detail. I'm not going to give for all four. First derived class takes title, price, and then pages. So pages and give us pages. Okay, all three are given for the first derived class. Now we have to create an object for the derived class, first derived class. So my first derived class name is book, and the object which I am creating is B. So inside the parameters, please remember, go to that constructor. So inside book I have 1, 2 and 3. I need to give for title, I need to give for price, and then I need to give for pages. Remember all these three. Don't worry about this inheriting part, because it will automatically allocate it from S to S, A to A. So come down. Now title already given as title, comma price, comma pages, semicolon. So that's going to be automatically allocated. The same we'll be doing for the second derived class. So title, price are going to be same. Here instead of pages, it's going to be play time for my second derived class. Title, price, and instead of pages I have time. And this is not book. My second derived class is named as tape, and the object I create is T. So far you're clear, I guess. So in the main function I have declared all the variables. For the first derived class, what I'll need a title, price, page. So all I have got from the end user using cin statement. I got the title, I got the price, I got the pages, and all three are going to be assigned here, and automatically that is going to be carry forwarded over here. So star S contain the title, A contain the price, and P contain the pages, and that's inheriting. So first it goes over here. So in the place of S, title is assigned. In the place of A, my price is assigned. So title and price I got over here, as well as pages in the first derived class. Likewise here for the second derived class for tape, I give title, price, new price, and the time. So that's going to be assigned here. So same way it is going to be taken to the second derived class, and that's going to be assigned to the base constructor also. So we all set. Now we have to focus on this overriding thing. We have a problem, isn't it? We have same function name in base class and two derived class. So to overcome that, we have to introduce a pointer. So we know we have to introduce a pointer only for the base class. So my base class name is media, and let me introduce a pointer star p. So we know what we have to do. First, for this pointer, I need to allocate an address. So let me introduce this base, derived classes address, first derived class. So address of B is assigned. Now using this pointer, I can call show off. This is one thing. And once I'm done, now assign my second derived classes object into the pointer. And now using that pointer, call the same function show off. That's it, we're done. Now you just tell me what happens. So when I create like this, remember I'm creating a base classes pointer, and using that pointer I'm just pasting the derived classes address into the pointer, and I'm calling derived classes show off. And again I'm doing the same. Second derived class address is point to the pointer, and using the pointer I'm calling the second derived classes show off. So we already saw very clearly, using the base classes pointer you can't access a derived classes properties. It's not possible. For your confirmation, let me run this program and I show it to you. There is an error here. I told you, isn't it? String copy. I didn't introduce a header file. Let's check what it says. String copy was not declared in this scope. So I have to mention the header file. So the header file is hash include C string. That's the header file I have to introduce when you use any new keyword like string copy, string concatenate. There are so many other things related to string. Now let me run the program. Again, there is an error. What it says, p arrow show off. Class media has no member named show off. Did I give any other name instead of show off? Oh, I used display, isn't it? That's my bad. Display is the function name. I forgot. Display. That's the function name. Okay, it's asking for the title. Let me say C++ is the book name. Price, let me say 256.20 something. Pages, let me say 156. And this is for the second derived class. So let me say Python as the title. And my price is 300.50. And the play time is something like 40 minutes. And it is supposed to print these details here, but what happens here? It is displaying the base display. It never comes to the first derived class display or the second derived class display. This is what we discussed in the previous program. It always goes and call the base classes function and not your derived classes function when it is overridden. So you know what we have to do. So to avoid this, I have to make the base classes function as virtual. So go to base class. This is my base class. Check here, media is my base class, and make this function as virtual. Now run the program and same title, C++, 254.10, pages like 256. Next I say Python, price as 200.60, play time as 50 minutes. You got the output. See the title C++, price so and so, pages so and so, first direct class details and second direct class details. That's how the virtual works in a base classes function. Guess you are clear about this. One more thing I would like to add. I introduced a pointer, isn't it? And then I used the same p to store one derived classes object into it, and then I skip that, and then I store the second derived class object into it. Say for example, I need to store both these details without overriding. Here you can say first derived class address is written in this pointer, and then I have rubbed that, and then I'm storing the second derived class address into the pointer. So finally you have only the second derived class address into the pointer. For example, if you want to call here, let me hide this display, and I'm storing two addresses into the pointer. If I try to run like this, so let me say C++, price 253.0, pages like 230, and next Python, price 200.30, and then play second 60. Look here what it is displaying. It is displaying my second derived classes detail. It skipped the first derived classes detail. That's what happens when you have one pointer that has been pointing to the both both the derived classes objects. But I need both this thing. I need both this b and t to be displayed. So in that case, what you have to do is I can create an array of pointer. So let me introduce something called array of 2, and here let me say this as array of 0, and let me say this one as array of 1. Now if I call array of 0, it gives my first derived classes detail. And if I say array of 1, it gives second derived classes details. Let's check. Now it's fine. I got my first derived classes detail and as well as my second derived classes detail. Just to make you understand how to introduce arrays in pointer. The same way you can introduce array in base class, in objects also. If there is a situation you need to introduce multiple objects, you can introduce array in this object also. But here in our case it is not required. It is possible. You can do array in wherever, for a variable, for a pointer, and as well as for the object. I hope you are clear about this virtual concept and as well as dynamic allocation and string copy and the header file and everything. So in the next video, let's learn about the remaining topics of the second unit, that is pure virtual function, and then we have virtual destructor and this pointer. Uh, and after this, we'll be moving on to the third unit. So we have one more video to cover to all those topics. I'll meet you in the next video. Thank you.